Hello everyone, welcome to my YouTube channel Target 100 in Mathematics by Shivesh Kumar Singh, and today we are going to discuss some advanced question for continuity. Okay, let's start the questions. In my previous video I have told you about the continuity of a function, where I told you that if a function has to be continuous at any point, then what's the condition for that? Left hand limit should be equal to right hand limit, and it should be equal to FA means value of the function fx at any real number a. Same thing, same concept we are going to apply here also. Now this is the question that prove that the greatest integer function is not continuous at all integer points. Okay, now greatest integer function, I am sure you remember that it is written like this: square bracket x, it is called greatest integer function, and its value will be always an integer less than or equal to n, less than or equal to n or x. Okay, now so it has to be an integer, that is for sure. Now we will talk about this. Let a be any real number, or you can say a be any integer. Okay, because we have to check for the integer. Now when a is an integer, then what will be fa? Fa will be equal to greatest integer of a, means it will be a because it is an integer. Now left hand limit will be what? Limit x tends to a minus fx, means it will be limit h tends to 0 f a minus h, and f a minus h will be equal to what? It will be limit h tends to 0 greatest integer of a minus h. Now if you remember, I told you what is the significance of h here. H is a very small positive quantity. So for example, suppose a is equal to 2 and h is equal to 0.0001, then a minus h will be what? 2 minus 0.0001. Okay, so its greatest integer will be equal to what? Its greatest integer will be 1, because it has to be less than the particular number. So this integer, this number will be less than 2. So definitely less than 2. What is the greatest integer? 1. So here greatest integer of a minus h will be equal to a minus 1, because what will be the integer just before 1? Integer just before 1 will be a minus 1. So what you can see here, fa is a and our LHL is a minus 1. So you can see here, since LHL is not equal to fa, therefore f is not continuous at x is equal to a. And what was a? A was an integer. It was a general integer. So you can write at last, therefore f is discontinuous at all the integer points. Okay, definitely you will write this line at the last. Okay, that is f is discontinuous at all integer a. Okay, like this you will finish the question. Now let's try to solve this question. This is show that the function given by fx is equal to, this is double valued function, sin x upon cos x plus sin x upon x plus cos x when x is not equal to 0, and 2 when x is equal to 0 is continuous at 0. Okay, so here you see this is the value of a. We have to check at x is equal to 0. So what you will see here, you will get fa means f0. F0 means value of fx at x is equal to 0. Value of fx at x is equal to 0. So it will be 2. Because here it is written at x is equal to 0, this function will be equal to 2. Okay. Now we will find left hand limit. Left hand limit means limit h tends to 0 f 0 minus h, because we have to check at 0, and it will be equal to 0 minus h means not equal to 0. Here we are not talking about greater than or less than. Here we are talking about only equal to or not equal to. Okay. So f0 minus h will be equal to first condition. So limit h tends to 0 sine of 0 minus h divided by 0 minus h plus cos of 0 minus h. Okay. Now after this it will be the question of limit. So what it will be, you see, sine 0 minus h means minus sine h. So it will be just, I am writing little directly. Okay. So sine h upon h, because negative will be cancelled out, and cos of minus h, cos of minus theta is equal to cos theta. So it will be h. Now put h is equal to 0. So sine h upon h when h tends to 0 is 1, and cos 0 will be 1, and 1 plus 1 equal to 2. Now you see FA and LHL both are equal. Now we'll find RHL also. So right hand limit is limit h tends to 0 f 0 plus h, because value of a is 0 here. So limit again 0 plus h will not be equal to 0. Not equal to 0 means first condition again. So it will be sine 0 plus h divided by 0 plus h and plus cos 0 plus h. It will be equal to limit sine, limit h tends to 0 sine h upon h plus cos h. Now put h is equal to 0 again. So sine h upon h is 1 plus cos 0 is 1 and is equal to 2. So what you can see here, since LHL is equal to RHL is equal to FA means F0, therefore F is continuous at x is equal to 0. This will be your final answer. Okay. Now next question can be, if fx is equal to 0, I think this question was in the board examination also. Okay. See, and these questions I have taken from NCERT exemplar or R.D. Sharma. Okay. Because these are some advanced level questions. So I thought you must discuss these questions. If fx is equal to this function is continuous at x is equal to 0, then find the value of a. Now you see, here you can do this question by two ways. Okay. First way is like you will find fa, no doubt. First fa means f0 and f0 is a. Okay. Now after this, maybe you, if you want, you can find LHL, or if you want, you can find RHL, because just we have to find the value of a. So I am doing it by LHL. LHL is equal to, or I will tell you both the things, it's up to you, whatever you want easy you can understand. Limit h tends to 0 f 0 minus h. 0 minus h will be smaller than 0. Yes. So first condition, and it will be, I am writing little here, limit h tends to 0 1 minus cos 4x. So 1 minus cos 4 times 0 minus h divided by 0 minus h whole square. It means it will be limit h tends to 0 1 minus cos minus theta will be cos theta. So it will be cos 4h divided by h square, means it will be limit h tends to 0 and 1 minus cos 2 theta. What is the formula? I am writing for you here. 1 minus cos 2 theta is equal to 2 sine square theta. So it will be equal to 2 sine square 2h, because it is half angle formula. So here you have 4h. So here it will be 2h divided by h square. Okay. Now if you remember one formula of limit, what was that formula for sine? One was sin x upon x is equal to 1 when x tends to 0. Its general formula is limit x tends to 0 sine to the power n x divided by x to the power n is 1. It means whatever value, whatever power of sine is in numerator, same power of the angle x should be in the denominator. So you see, what is the power of sine? 2. And what is the power, angle with sine? 2h. So it means in the denominator we should have 2h square, means 4h square. But in denominator what we have? Only h square. So what we are going to do here? Multiply numerator and denominator by 4. Okay. Now this will be equal to 1 using this formula. Okay. This one. Now this is equal to 4 times 2 means 8. So since f is continuous at x is equal to 0, therefore LHL must be equal to f0. It means a must be equal to 8. This is the answer. Okay, but I want you to understand by another method also, by using RHL. See, my focus is how to calculate this algebraic limit also. In the first one I told you a trigonometric limit. Now you see how to calculate the algebraic limit. Or you can do one more thing, you can pause the video and then you just try to do it yourself by RHL. So it will be f0 is equal to a. Now RHL will be limit h tends to 0, f0 plus h. f0 plus h means more than 0. More than 0 means third condition. So it will be limit h tends to 0 and it will be square root of 0 plus h divided by square root of 16 plus square root of 0 plus h and minus 4. Okay, now we have to simplify this limit. It is equal to limit h tends to 0. It will be square root of h over square root of 16 plus square root of h minus 4. Okay, now you see here we cannot put h is equal to 0. Why? Because it will be in the indeterminate form. So what we can do here? We can multiply numerator and denominator by the conjugate of denominator. So it will be just write positive in between and numerator also multiply with the same expression 16 plus square root of h plus 4. Okay. Now what it will be in the simplified form? Limit h tends to 0 square root of h times square root of 16 plus root h plus 4 over, now you see denominator is in the form of a minus b times a plus b. So it is in the form of a square minus b square. Now 4 square 16 and minus 16 cancel. After that root h will be cancelled and now put h is equal to 0 in the remaining expression. So it will be square root of 16 plus 4 means 4 plus 4 and is equal to 8. You see by RHL also we got 8. So FA means A, F0 means A will be equal to 8. Okay, like this you can do the question. Okay, now next question is show that the function fx is equal to, again this I think this question has come already in board examination. Okay, and it is very important question you see. So we have to prove, okay, we have to show that the function is continuous that x is equal to 0. So what we can do here, first we will find fa means f0 is equal to 3 by 2. Now let's talk about LHL. LHL will be limit h tends to 0 f0 minus h means limit h tends to 0 minus h means smaller than 0 means first condition. So sine of 3 times 0 minus h over tan of 2 times 0 minus h means it will be limit h tends to 0 sine 3h upon tan 2h. Okay, why? Where is the minus sign is gone? Minus sign of numerator and minus of denominator both will be cancelled out. Why? Because sine of minus theta is equal to minus sine theta and tan of minus theta is equal to minus tan theta. So both minus sign will be cancelled out. Okay. Now again I am going to use the same formula. See, sine h upon h is equal to 1 when limit h tends to 0. So here what you can see, what is the angle with sine? It is 3h. Yes. So in denominator you should have 3h, and same goes, same formula with the tan also, or you want then you can convert tan into form of sine and cos. So what you are going to get here, it will be limit h tends to 0 sine 3h upon 3h. What I have done here, I have multiplied numerator and denominator by 3h, and then in denominator it was tan 2h. So I have multiplied numerator and denominator by 2h. Now this will be equal to 1. This will be equal to 1. H cancelled out here, and what you will get? 3 by 2. Now you see FA and LHL are equal. So we are going to check for RHL also. Okay. And what I am going to do here for RHL, I will erase it all. Okay. See, I'll erase it. F0 was 3 by 2. Yes. So, and it was equal to LHL also. Now we are going to find RHL. RHL will be limit H tends to 0, F0 plus H, and it will be equal to limit H tends to 0, and then it will be log of 0 plus H means more than 0. So log of 1 plus 3 times 0 plus H over e to the power 2 times 0 plus H minus 1 means it is limit H tends to 0 log of 1 plus 3H upon e to the power 2H minus 1. Now here we are going to use two formulae. One is limit x tends to 0 log of 1 plus x upon x is equal to 1, and another formula will be limit x tends to 0 e to the power x minus 1 upon x is equal to 1. So it will be limit h tends to 0 log of 1 plus 3h. Now you see here we don't have h, we have 3h. So in denominator we want 3h, and numerator also we will multiply 3h. Okay, multiply. Then in denominator you have e to the power 2h minus 1. So in numerator you want 2h. So here also you will multiply by 2h. Okay. Now this expression will be 1 with the limit. This expression will be 1 with the limit. H is cancelled out, and again we are getting 3 by 2. So since LHL is equal to RHL is equal to FA, therefore F is continuous at x is equal to 0. Okay, like this you can finish this question. Now another question is find the values of a, b, c for which this function is continuous at x is equal to 0. Yeah, I think I remember this question. This question was in CBSE board examination in 2014. Okay, see, this is same process we are going to do here. F0 is equal to c. Now we will check for LHL. LHL is equal to limit h tends to 0 f0 minus h, and it will be limit h tends to 0 f0 minus h means smaller than 0. So sine of a plus 1 into 0 minus h plus sine of 0 minus h over 0 minus h. Now it is limit h tends to 0. Now you see minus sign, minus up, minus down. I am taking common and it will be cancelled out. So you are getting sine of a plus 1 into h plus sine h upon h. Now write it separately. So it will be limit h tends to 0 sine a plus 1 times h upon h plus limit h tends to 0 sine h upon h. Now you can see this will be equal to 1. Okay. And what about this one? Here we have a plus 1 into h. So in denominator we want a plus 1. So in multiply numerator also with a plus 1. So what you will get here? A plus 1 means a plus 2. Okay. So F0 was equal to C and LHL is equal to a plus 2. So one equation we got here, a plus 2 is equal to C. Why? Because value of x that we have to find the value of ABC and function is continuous at x is equal to 0. So LHL will be equal to FA and it will be also equal to RHL as well. Okay. So A plus 2 is equal to C, or C is equal to A plus 2 we are getting. Now for RHL. Okay. I am erasing it all so that we can write for RHL also. This is now. So one equation was A plus 2 equal to C and F0 was equal to C. Okay. Now I am trying to find RHL. It will be limit h tends to 0, f 0 plus h, and it will be equal to limit h tends to 0, 0 plus h means bigger than 0, bigger than 0 means third condition, so it is square root of 0 plus h means h plus 0 plus h whole square means h square minus root h over b times h to the power 3 by 2. Okay, here I have done it directly. 0 plus h means h, and it will be limit h tends to 0. Now, we cannot put h is equal to 0 here because it will come in indeterminate form. So, what we can do here? We can multiply numerator and denominator by conjugate of numerator this time. So, it will be h plus bh square, h plus bh square plus root h upon same expression denominator also h plus bh square plus root h. Okay. Now you see numerator is in the form of a minus b times a plus b. So it will be a square minus b square. So h square h minus bh plus bh square, that is a square minus b square means h over b h to the power 3 by 2 times root h plus bh square. Okay, you see here I think we can take something common as well. So root h can be taken common. So root h common, so it will be square root of 1 plus bh plus 1. Okay, now h is cancelled out, b is cancelled out, and here we are getting limit h tends to 0, h square upon h to the power 3 by 2. So what it will be? It will be h to the power 1 by 2. Okay. So h to the power 1 by 2 means root h upon root h times root 1 plus bh plus 1. Root h also cancelled out. Now put h is equal to 0 here. So you will get 1 upon 2. Okay. See, RHL is 1 upon 2. FA is equal to C. So it means C will be equal to half. That is one answer. And A plus 2 is equal to C means A plus 2 is equal to half, and B, then A will be equal to minus 3 upon 2. 1 by 2 minus 2, I think it will be minus 3 upon 2. So see, we got two values, A and C we got, but where is B? B we did not get anywhere, yes, because B is available only in the third condition, and that is for RHL, but B is cancelled out. We are not getting B. So what does it mean? It means continuity of the function does not depend on B. So what you will write here? B belongs to R. Okay. Because of this statement only, very few students scored 100% marks in that time. Okay. Because they did not mention this B belongs to R. So what you will write here? Answer will be A is equal to minus 3 by 2. B is any real number. It is not necessary that you write B belongs to R. You can write for all real number B, okay, or B is any real number, whatever you want. And C is equal to half. This will be the complete answer. I am sure these important questions you have understood, and if you think that such videos will help you to increase your knowledge, please like and subscribe my channel and share with your friends also. Thank you.